Hi and welcome to Berkshire Guitar Amplifiers. Stuart Smith on the bench as always, and today we're going to be looking at the second of the two Selmer Little Giant amps that I had bought into me. I did a video on the first one which was the same as this but a clone, it wasn't a Selmer brand. So have a look at that video if you're interested, and today we're going to be looking at the Selmer. So we have here the original Little Giant from the 1960s. Fairly simple amplifier, mass produced, really manufactured as cheaply as possible. This one has an EL84 operating class A and a single ECC83 on the front end, bit of gain, bit of tone, and this one has a valve rectifier, EZ81. Ostensibly 4 watts, but as we saw with the clone of this, it only produced 2 on a good day. So I'm expecting this to produce 2 or 3 watts maximum. That gives it a kind of nice grungy sound. It doesn't take much to overdrive this amp, and it sounds like it's got a distortion pedal on the front end of it if you give it any kind of input signal. Well, let's get the back off and see what this one's like inside compared to the clone, and then we can set about finding out what we need to do to get the thing up to scratch. And here we are inside. So let's walk our way around this so that you know what's going on. Obviously start off with a speaker, 6 or 8 inch, I'm not quite sure what. That's a 4 ohm speaker. Again, quite a sort of cheap and cheerful speaker. You won't get any fantastic tone out of something that small. Over here we have, look, the mains transformer here. That's going to be producing the heater voltages and the HT voltage. Here's the output transformer. That's a suitable size for a 3-4 watt amplifier. You don't need anything bigger than that. In the clone of this we had a whacking great big output transformer, which I think had been added by somebody else. Off, on switch and volume control. This has been replaced, I think. That looks, yes, that looks quite new. That's been replaced. It's not original. And whilst we're on the on, off and input side, here is the mains input lead. This has been replaced. Look, it's the British standard yellow striped green, blue for neutral, brown for live. So it's a modern cable, and it looks like it's come off of an electric iron. That's an electric iron replacement cable. Perfectly okay, nothing wrong with that at all. Now looking at the valves. Well, first of all, notice that our HT cap here has been replaced. That's brand new, and so we don't need to worry about that. Valve rectification, rectifying the AC to produce HT, and EL84 in the driving stage, driving the power transformer. So this is our power stage. We'll pull these valves and see if they're in good condition. In fact, I've just remembered that when I did the video for the clone of this, we had a brief tour around this amp. That was a few weeks ago, and when I opened up this amp, this valve was missing. So that's me who's put that JJ in there. There was no preamp valve in the amp when I got it. And then on the printed circuit board we have the usual, old carbon resistors, some tone caps. This is almost certainly the bypass capacitor for the power valve, so I'd probably like to change that. I'm not sure what this hulking great big power resistor is there. We do have the schematic for this amp. I'll show you that in a moment. There's very few components on it, really, aren't there? It's very cheap to produce this. Just a tiny handful of resistors, a couple of capacitors, and job done, really. Another cap down there. Nothing much else to say, really. I think that's it. Well, let's have a walk around the schematic together. And this is the actual schematic for this amp, so that's very useful indeed. Okay, so mains transformer coming in, look, and we have our EZ80 valve rectifier to produce the HT DC at this point here. A couple of 100 volts, 250 or something at most. Actually says 240, 240, so that's quite interesting. so we won't have much more than 240 volts of HT there. And then smooth look by that capacitor, dropper resistor there, a bit more smoothing to get rid of hum, and this is fed off to the screen of the EL84. Now we have again quite a large resistor, 100k, dropping down the HT again to provide the HT for the preamp valves. And as I mentioned on the clone, if you saw that video, this is quite a big resistor, resulting in a lowish voltage here. I think it was about 120 or something on the clone. And then we have these two large 270k resistors in the anodes of the preamp valves, again resulting in quite a low voltage on the anodes here. On the clone it was like 60 volts and 30 volts, or 70 and 40, I can't remember exactly. So surprisingly low voltages on these anodes, so I expect to see the same here. Right, so start somewhere. Power amp side look, EL84 in class A. So this resistor here sets the bias, in other words the tick over current through the EL84. The bigger that resistor, the smaller the tick over current. This bypasses AC so that this doesn't soak up any of the amplification of this valve. AC goes to ground, so this looks like a short circuit to ground AC wise. DC wise it sees this resistor here. Input, standard input stage, output through the output transformer, speaker hanging on the winding there, look. HT look comes into the top of the output transformer. So this is just class A, kind of up and down, up and down. Input signal comes in here, coupled in here from this second stage, this is just providing a little bit of gain recovery after this very simple tone control here. Input again, standard input stage, producing a bit of gain there, or a lot of gain. One of the reasons they might have picked these 270k resistors is to give a bit more gain, because normally you'd want one or two valves here to get us a decent gain. But I think they've skimped on this and got the maximum gain they can out of one stage by putting a big resistor there. That's my guess anyway. Simple tone control look, just this pot shorts this capacitor to ground, or not as the case may be. Very crude, very simple. Heaters look, and the on-off light. Job done. That's your lot, that's all you've got. The next thing we're going to do is power this up. I powered it up on the clone video, so I do know it works. So it all works. About 1.5 watts of clean headroom there. As soon as you put any signal in at all, it distorts like crazy. And I think that's probably what it was supposed to sound like. What we'll do now is to put it up on dummy load and have a look on the scope to see what it's producing output wise, and then we can decide what we want to do with the amp. Well, there you go, there's the output into 4 ohms, and it is 2468 volts peak to peak. And if we go any higher, we do get a little bit more, but of course it rapidly squares off, look. And 2468, 10 volts peak to peak. So let's plug those sums in and see what we're getting power output. 8 volts peak to peak clean, which is better than the clone did, and 10 volts peak to peak dirty. I've done the sums so that you don't have to. and 8 volts peak to peak is about 2 watts into 4 ohms, 10 volts peak to peak is about 3 watts. So my guess is that this amp never produced 4 watts in its entire existence, and that's basically 2 watts clean, 3 watts dirty. Okay, so that's that. Now we have to decide what, if anything, we want to do with the amp. It's basically working. So now it's a question of deciding how involved we want to get in the amp, how much work we want to do. Bearing in mind the customer wants to sell it and it's basically working, I think as a minimum I would want to change this bypass capacitor. I want to check what current's going through this EL84, because on the clone it was pulling 60 milliamps, which is very hot. I reduced it to 30 milliamps by dint of increasing the value of this cathode bypass resistor here, cathode resistor I should say, 130 ohms. I made it, I think, 470 on the clone. So let's see what current's going through there. Test the EL84, see what current's going through there, change that, and then have a think about changing some of these carbon resistors. Unfortunately, this amp's not particularly easy to work on. I can't immediately see how to get the chassis out. There are obviously some bolts coming through here with nuts on holding the chassis in, but on the other side of that you've got the flush grill cloth. You can't get to the heads of these bolts, so I'm kind of hoping that if I undo these nuts here, they will just leave the bolt fixed in place and the chassis will come out. Could actually be a little devil to get the chassis out of here, so I'll take a view on whether we actually want to do that. How would it play? In case you haven't seen the video I did on the clone, here is the situation regarding the HT. Now just to remind you, the HT comes in, goes via a 4K7 resistor, and that becomes the preamp HT, you might call it. The HT before it's conditioned by these resistors, then it gets dropped down to 100k here to feed these two 270k resistors which go to the anodes of the preamp valves. So the readings I got were on the Selmer, the one we're working on now, at 276 volts HT versus 216 on the clone. We had some problem with that clone amp in that it just wasn't producing enough HT. Then we get dropped down to what we might call the preamp HT, not a very good term, but there you go. The Selmer's got 240, the clone had 190, and then point A, after being dropped by this 100k resistor, we got 132 on the clone, 160 on this one here, and then these two voltages here were 77 and 70, 49 and 39. So it looks like these preamp anode voltages here are designed to be quite low, you know, 75, 50 volts or whatever. Unusual that. Well, I would normally on a guitar amp expect this to be 125 volts or something. So it's abnormally low by my experience, but if people watching this, if they're used to working on very old gear like that, might be thinking, no, that's perfectly normal to have a 60 volt anode. EL84 has just passed its test and it came out good. Make is it's a tongue SRAM valve, not one I come across very often. Probably the original valve. So we can pop that back in, put the clip back on, and now the next thing I'm going to do is just have a little play to see how hard it is to get this. I made life difficult for myself there. How hard it is to get this chassis out. Right, it was a bit of a mission, but I did manage to get the baffle board out here. Real kind of weird system. It's all very Heath Robinson basically is the problem. Right, so now we can actually get access to the underside of the PCB, which is useful. And we can think about changing resistors or whatever. Now I want to find, first of all, I want to find this 130 ohm cathode resistor here. Can't immediately spot it. Then I can measure the voltage across it and we can work out what current's going through this EL84. So let's see if we can find 130 ohms. There's the resistor there, that 150 ohm 5 watt. It's marked 130 on the schematic, but there's a 150 in there. That looks kind of original. No idea why they need such a big wattage resistor. You don't need a big wattage resistor there, not huge anyway. So now we can measure the voltage across there and see what current's going through this EL84. And if it's stupidly high again, I'm going to reduce it again and put a larger resistor in there. I don't really like these things running really hot. They shouldn't be running at that kind of heat and current level. But anyway, let's see what it's doing. Right, I've got this set up now. I've just got a couple of wires tacked across that 150 ohm resistor, bring it out to a voltmeter, and it's looking like we've got about 7 volts maybe. That's pretty much warmed up now, give or take. So let's see what that translates into in terms of current through the EL84. Well, you don't need me to tell you this, but just in case you do, Ohm's law. We know the voltage, we know the resistor, therefore we can get the current from I equals V over R. V is 7, divided by 150 ohms is 46 milliamps. So that's kind of on the high side. I prefer about 30, but I think I'm going to leave that. I think that's probably okay. The other one was 60, so that was just way too hot. 40 milliamps is not too bad. Right, so the next thing I want to do is turn off the amp, which I have, and we want to measure some of these resistors here to see how out of tolerance they are. So I'm particularly interested in these two 270k resistors. One measures 300k and one measures 350k, so they are well out of tolerance. Let's now check these 100k, this one here, and see what that's doing. Having trouble getting on there at the moment. 104k, so that's okay. Don't need to change that. So I'm going to change the two 270k resistors there and that capacitor there, and I think that's all I'm going to do. There are different views, of course, on how you restore an amp like this, and you know, one view is that you just change everything, it's all 60 years old, just blitz it, put all new components in. Another is to do the absolute minimum, because this is a kind of vintage piece of equipment. Do the minimum you can and leave the rest for somebody else at a later date. I subscribe slightly to that view of things, depending on the piece of gear. If this was worth 30 quid on eBay, I probably would go and change pretty much everything. But because it's worth £1,000, it's obviously got some sort of historic and vintage element to it, and we want to preserve that as much as we possibly can. It's the same with any kind of restoration, really. You want to do the minimum you can. And there's nothing lost here. It doesn't matter in a way. Let's say I choose not to change this capacitor, and in 6 months' time or 2 years' time it develops a fault because that capacitor has gone faulty. It's completely unimportant. It's not a gigging amp or anything like that. The customer will just bring it back in. I would diagnose that faulty capacitor and change that capacitor. That might happen in 5 years, 10 years, 25 years, or never. So again, when you're restoring something, you need to ask yourself, how critical is it? This has to be absolutely right. It has to 100% work. It really cannot have any faults on it whatsoever. Well, that's just not the case with something like this. If it goes wrong, it'll come back. So we want to do the minimum, really. We always have to change these electrolytic capacitors. They've got a 20-year life, and this is the one I took out of the clone was this one here, look. And this is 60 years old. Never even heard of TCC multi-pico pack electrolytic. And the funny thing is, it's probably still okay. But electrolytic caps, 60 years old, you don't really want to be leaving those in. Someone has done the same with this one. They've decided to put a MA cap in, again not a name I recognise, and that's been done quite recently, I think, I'd guess in the last few years. Right, so we're going to change those two resistors and that capacitor. That's another electrolytic capacitor, 60 years old, and then I think we're going to call it job done on this. Leave well enough alone. Just before I change those resistors, you remember I commented that that 150 ohm resistor is just way too heavy at 5 watts there. Let's just see what that is actually taking, that resistor, DC wise at least. Well, we know it had 7 volts across it, and we know it's a 150 ohm resistor, so the power is given by V squared over R. So 7 times 7 is 49, divided by the resistance, which is 150 ohms, is 0.32 of a watt. So a half watt resistor we're doing there, and a 1 watt to be extremely safe. 2 watts if you're really ultra careful. Obviously there'd be a bit of AC power going through there when the thing's running, but not very much. Most of it will be this steady state DC going through. So God knows why they put a 5 watt resistor in there. Just thought I'd let you see that. So I've just removed one 270k resistor, and you can see out of circuit it measures 330k, which is significantly higher than it should be, and will result in a lower plate voltage on that side of the preamp valve. So we'll change that one, then we'll take the other one out and check that one too. And here's the other 270k resistor at 370k. So absolutely massive difference there, 40% or something more than it should be. So it's a good idea to change these two. Right, I finished the modifications. I have changed the cathode bypass capacitor, changed that 470k and that 470k. I also decided to change the cathode resistor in the power tube from this probably 3 watt 150 ohms to a 2 watt 220 ohms. And I've done the measurements, and it's reduced the current through the EL84 to about 35 milliamps from 46 milliamps, I believe it was. So that's a little bit more sensible and a little bit cooler. So there we go. I'm just going to connect the speaker up again and make sure that it all still works, and then I think we can call it a day on that. Okay, all back together and all working. That's the clean side of things. When you play loudly, quite grungy. It's quite a nice distortion actually. So maybe that's what people are looking for when they buy these amps. I don't really know what they're looking for, to be honest with you, but anyway, there you go. So I'm happy with that. We've changed certain components and put a new valve in. HT cap's good. I think we can pop that back in the cabinet and consider that job done. Well, here we are, all working. Dirty and sweet little back, don't look back, and I love you. You do so sweet, oh yeah. When you hit it fairly hard, the clean sound, and the dirty sound is There you go. Well, I hope you enjoyed that look at this very rare and sought after Selmer Little Giant. I've never seen one before, so that was quite interesting for me to have a look inside. I think we've done all we sensibly can. Obviously we won't go on and on and on spending money. And then do you end up with the amplifier as it was, or do you end up with a completely rebuilt amplifier? Always a difficult thing to decide, but I think we've done probably the right amount of work on this amp. Okay, well, thanks as always for watching. I'll see you on the next video.